everyone to Technium's end-to-end webinar series. Today, we are officially kicking off this series with the first of 4 webinars. Michael Joseph, Technium's co-founder and CTO, will be presenting Your Internet Reimagined. Mike has 30 plus years in the network and security field and has a passion for developing talent and helping businesses streamline their security. Throughout his career, he has worked at the company that built the internet, worked with the U.S. Air Force, and has led Technium to be a successful service provider for global companies. If at any point you have a question, please use the Q&A feature to submit it to the speaker. We will answer as many questions as possible at the end of this presentation. Also, towards the end of the webinar, we will be sharing a survey link and would appreciate your responses. With that, Mike, I will hand it over to you to present Your Internet Reimagined.
Thanks, Katie. So first of all, I think one of the sort of prominent questions we're going to hope to answer today is the fact that I think most people don't really know how the internet works. And the reason that's important is because businesses have grown to be very dependent on internet technology. And one of the things I think I'm going to challenge today is the internet itself actually the right way to do business? So does it matter? So if you do rely on the internet connectivity to run your business, and if we think about the evolution of technology over time, I think it's first and best to start with, where is the network taking you? What is the purpose of the internet? It's to get from point A to point B, and we're showing 3 different evolutions here, and I'll talk to them in a little bit because I think it's important as sort of a lead in to how this sort of disruption that we're going to talk about, in at least regionally, and how you can access information is going to be sort of very important. So we started off maybe 30, 40 years ago with all data was fairly localized to the building or to the campus environment. So all of the servers, all of the network infrastructure, all the complexity was built in support of that. The next evolution was we were moving to more of a third-party data center structure. And as these evolved over time, the ability to put your environment together in a third-party data center was very attractive because we could ensure that you had very resilient power, air conditioning, security, etc., and integrating these third-party data centers into your designs. So networks evolved from local network structures to wide area network structures that included data centers, right? And so then the next evolution, which is maybe 20 years in the making, is cloud. And cloud is essentially third-party data centers run and delivered to you as a service. So your data is essentially, when you're accessing Amazon, SaaS, or other third-party cloud resources, it's going from the path, the way the internet needs to be worked, the way the network and wide area network and internet need to serve you is from your local environment, your local building, to these cloud environments. So let's take a look at how, and this really is the first depiction of how the internet actually works. So the internet is essentially, and what's great about it, and being involved in it for so long, I think it's just one of those wonderful stories, is that it is not a business. It is not an owned entity. The internet is essentially a collaboration between entities with a certain amount of controls that have evolved over time. And then material changes within the internet, such as cloud, are added as overlays to the way the internet and network topologies have been built. So if you look at this, what I'm showing here is we show all of Amazon's major regions as an example, right? So if you're using Amazon technology and you're here in the Boston area, you're most likely standing up all of your resources, or the majority of your resources, in the US East data center, which is located in Northern Virginia. So your traffic is starting from your home, office, lab environment, going down to the US East facility. Now, it doesn't necessarily flow through the Markley data center, but the reason I would advocate that a high percentage of your data, and most probably the majority of your data, is going through this data center is because, as depicted here, Amazon has chosen to leverage the Markley data center as part of its edge network. What this means is that Amazon networking is extended into a cage residing in the Markley data center in downtown Boston. And the reason this is important to us in this region is if you're accessing Amazon, if you're accessing Microsoft infrastructure, if you're accessing Google infrastructure, it will either be designed to flow through this data center, or it will, because of the way networking works, it will just naturally flow through this data center. And since Microsoft, Amazon, Google, and many key cloud providers, SaaS providers, are located in this Northern Virginia area, the natural path is to flow to Markley down to these facilities. Quick interjection here. We've also added to the conversation Lee Henning from the Markley Group. Lee and Markley are a key partner here at Technium, and I just wanted to make sure everybody knew he was on the call at the end of this, because he is much more technical and can answer much more in-depth questions about the way the service that we're talking about and even the topology works. Lee's background includes being a principal network architect at Markley, as well as having spent 6 years in Amazon building out a lot of the network infrastructure for Amazon. So just welcome, Lee.
Hi, thanks for the introduction. Any questions? I'm happy to go through in detail at the end.
Thanks, Lee. So where we are in our story is this picture here shows a fraction of Amazon's data centers in Northern Virginia. And it's hard from this picture to see this, but the immensity of these buildings, you know, if you look at the building at the top compared to, let's say, a tiny little house on the left, these are tremendous facilities built optimally from a physical and infrastructure perspective. And just to sort of the purpose of showing this is where your data is going. This is the pathway to Amazon, and this is just a small fraction of what they have. So just kind of connecting the dots here and really unifying what we've been talking about so far. As we look at the potential for disruption, if we look for the opportunity to enhance the experience, what you see here is that the Markley data center, which is a privately owned, ranked #1 by Amazon as their optimal third-party data center globally. Out of 272 global data centers, the Markley data center is the #1 ranked facility. It is our internet edge for Amazon, and it is one of 7 telco hotels in the United States. So in addition to that, as we see here, what is a local zone? So a local zone is essentially an extension of a region. And again, we'll let questions flow to Lee at the end of this, but the local zone concept is Amazon, as part of its extended network, builds out local zones to create proximal services in a region. And what we're, again, very fortunate about in this region is that there is momentum that has begun to outfit this local zone with a substantial number of services. Within the year 2023 into the year 2024, the capabilities of the Boston local zone are going to be dramatically enhanced, enabling proximal workloads. This is great for very, very latency sensitive applications. It's also great for workloads, particularly in science and finance and other areas that might require very, very sensitive experiences for the application itself. So this local zone that is being built on behalf of all of the different businesses here in the region is going to be an exciting extension to this network in our region. So now let's break it down a little bit. right? So we've talked about how the internet works. We've talked about the evolution of data over time. And now one of the key things to start talking about is how does your data actually flow? So in this picture, what we see, very, very simplified, is we see an office, we see a local data center, which is Markley, and we see US East. So the traffic flow is simply, as I hope I've proven, the likely path is from wherever your office is, as it's trying to get to these SaaS and cloud applications, it's likely to flow through the Markley data center. So we've got two pieces of a puzzle here to deconstruct: the path from the office to the data center, and then the experience and the services offered from the data center. So what we'll do is we'll first take the first piece of the puzzle, okay? So this is just an example, but imagine if you have an office located in Cambridge, and we depict the office over here on the left, and on the right-hand side is the Markley data center. And what we'll see next is circuits. Okay, so this is pretty much an accurate depiction of an experience that we had with a customer that had designed what they thought was a highly available set of circuits. They had an Amazon Direct Connect, they had 2 internet connections. Unbeknownst to them, all 3 of those circuits, even though they were using 2 different providers, flowed over the Longfellow Bridge. And so they thought, I've got 2 service providers, I've got inherent diversity, I'm good. Well, now what can happen? So what did happen was there was a fire on the Longfellow Bridge. That fire impacted the telecommunications services running across that bridge, and there was a total outage. And that could have been avoided if some thought had been put into how the actual network pathways can be built. So we need to work on a solution for this. So this is the problem. Now let's look at the other half of the equation, which is most businesses, as they design their services or use their services, they don't really put a lot of thought into the traffic engineering that might benefit them in accessing services that they're consuming. So what you'll see here is most of that data is flowing down to the Markley data center. It's typically an unstructured cloud connection or wide open internet, sometimes VPN, and it's all flowing essentially over an unknown opaque path through the Markley data center to these locations. And we can, in this instance as well, see failure events. Again, they're not predictable, they're not solvable, they're not efficiently using any of these resources. So how your data actually gets to Virginia is an unknown pathway from your office down to Markley, and then unstructured down to US East or other cloud locations or the wide open internet. So none of this is transparent. None of this is clearly identified how it works. And there's obviously risk because of the lack of knowledge. So summarizing the problems that we've sort of experienced in working with companies in this way, and until we sort of solve some of this, the first one is obvious: redundancy issues. We saw that in both sides of the equation. In the event that you've provisioned traffic down an unknown path over a single bridge, possibly crossing different POP locations. POPs are points of presence. That could be that telecommunications providers share locations. There could be common poles along the way. The redundancy issues are numerous along both of those pathways. This one we didn't talk about yet, but it's important. You typically will establish contracts with your vendors for services that have very prescriptive services. So you can only have 1 gig of internet bandwidth. You have a 1 gig direct connect. You have a 100 meg internet backup. All of these are defined, and then to change any of that, you have to recontract. You have multiple contracts. So you have relationships with multiple parties. All of these contracts have to be built and managed by a team, and you have a latency issue. So the reason I say you have a latency issue is because wide open internet is no guarantee of latency. And the way I like to talk about latency is what's the most important thing in user experience is consistency. It's not great performance followed by bad performance, it's consistent performance. So what we as network engineers strive for is highly predictable, very consistent latency. And again, latency is the measure of the time it takes to go round trip from point A to point B. So we want that to be consistent. We can't guarantee that in the previous designs I showed you. Since none of this is transparent, it's all this sort of like opaque path between point A and point B. Troubleshooting issues involves, first of all, trying to gain visibility into how the traffic is flowing and where the problem might be. You end up with issues that we sometimes classify as black hole issues, meaning they go into a provider, somehow there's a problem, the traffic never comes out the other side. And finally, you actually have to get help in troubleshooting a lot of these issues. You have to engage with the telecommunications providers, you have to engage with the equipment providers and deal with any issues you might face along the way. And our whole goal is to simplify so that we troubleshoot less. And the last issue, which is not going to be really a prominent part of today's talk, but will be a big part of future talks in the webinar series, is security is on you. You need to define and maintain your own security. And we've been working on some innovations in that area as well. So here's our summary of issues. Now, how has Technium and Markley reimagined the internet? So let's talk about how we could do this better and different and have done this better and different. So let's go back to our problem set and let's solve it one leg at a time. So the first thing you can do is you can actually, and this is possible, and we've done it a substantial number of times for customers now, customers can engage and do this, is create transparent, clearly separate pathways between the building and Markley. So this is basically point-to-point fiber optic technology with guaranteed contract-based, never to cross, never to overlap, what they call grooming will not be done to put these two circuits in any way in an overlapping position. There's always the case of, do you have different entry points into the building? So we need to face that challenge together. But the number of reduced complexities in this one picture is substantial. We've reduced the pathways to go over two different bridges. We've reduced the active components to basically none. This is passive optical all the way through so that the troubleshooting is much simpler. And we've reduced the risk of future state changes causing impacts on us because we've contractually bound these two circuits to never overlap. So this is a huge advantage. And while this can sometimes be slightly more expensive, what's been shocking, absolutely shocking, is that the degree of cost increase of a service that is often substantially more capable, larger, less complex, is nominal in comparison to what you're probably paying today. So that's one half of the equation. So now let's go to the other half, and this is where the real magic happens. So this is where we imagine something that could be connected to those two circuits. While those two circuits often makes the biggest impression when I show this path, this solution, the real magic happens here. So what we see here is, again, the complexity, but let's transform that into something different. So we built this really amazing service that we call the Fabric. And in many ways, it's a simple concept, but it brings together all of the advantages I've talked about so far that we have in our region. First of all, it's built and operated within the Markley data center, which is the internet hub location. I've proven that, I hope, through the talk today. So this is the place that's most proximal to the cloud services. So we've built it right in there. That facility is a very unique facility, so that the facility is great. And then what we've done is we've made it very easy to multiplex on those two circuits all of these things that I'm depicting here. You've got all of your major cloud providers, you've got blended data center internet, you've got the Boston Internet Exchange, all of which I'm going to talk about a little bit more here. But if we put together these two things, This is where the magic of this solution and this transformation happens. And this red overlay here is, again, a little bit of a tip to our future state topics. This is what is coming as a next gen set of services, security as a service on top of the fabric. So now let's recap how we're solving things and the benefits of this compared to the challenges we showed. So the design and every element of the design has been built what I like to call carrier grade. So carrier grade in the world of telecommunications means we eliminate all single points of failure and we ensure that capacity and performance management are part of the solution. So the architecture of the fabric has complete resiliency. All aspects of it are separated physically. We connect multiple connections on the fabric, and we've really thought through all pathways in and out to make sure that there is no single point of failure. In addition, it resides in a building that is one of the few, if not the most prominent location here in the Northeast that practices 2N power. Power is often one of the biggest problems that you have in data center environments. If you have a power issue and you use N+1, so the difference between 2N and N+1 is N+1 means I have N pieces of equipment and I have a single piece of equipment as backup to any one of the failure items. 2N means I have literally a like for like piece of equipment for everything I have in production from a power standpoint. So all of the power in this facility is 2N. We also have some other advantages. Again, these are almost like kick-ins for being in this environment. You've got blended internet, which means when you're handed internet off of the fabric, when you're getting direct internet attached off of the fabric, you're automatically getting multiple internet service providers provided to you, which means you don't have to worry about the resilience of your internet. It's just handed to you as a service. In that location, in addition, should you need to interconnect in a more global manner, there are hundreds of network providers, that both domestic and international, that land in this facility, so interconnecting is optimized. And then there's also the Boston Internet Exchange service. So we're going to talk about that a little bit more as we go through, but at a very high level, what it is this is, in the world of networking, this is one hop away services. So this is companies that have come together and made available in an exchange access to their applications and environments in one hop. So what this means is, for example, if you're in the biotech life sciences space, the Broad Institute is on the Boston Internet Exchange, and you can be assured that should you connect with the fabric, you are one hop, one consistent step away from accessing the Broad Institute. That's an example. Transparency. That is the biggest thing that when we're trying to troubleshoot issues or we're trying to fix problems in your environment, this is maybe the biggest simplification that we've achieved from this overall architecture. Is we can see from the source point, from the office, from the end user, all the way through the path to the end connection all the way down in US East, because we have these simple fiber pathways. They land on a device that we have visibility into, and that device is cross-connected directly to the Amazon network. So the last thing, and again, this is for future state, security is monitored, maintained, and remediated by Technium. This is both optional in the sense that there are some services that can be chosen or consumed, and it's also included in the sense that the elements of the fabric and the maintenance and security of the pathways that I've described are actually fully maintained and secured as a service. So this is our complete list. So how could this help my business? How could this help you? Well, one of the use cases that we run into is if you would like to move to the cloud, but are not sure how to do it in the right way. We've seen a whole host of opportunities here. First of all, you can access a single cloud provider and start and for a very low cost, if you're already utilizing services here, and let's say you're taking advantage primarily of SaaS services and you want to consider putting some workloads in Amazon, for a nominal cost, you can get a very low latency, high speed connection to Amazon and start moving workloads in and out of Amazon very easy. If you're using a lot of Amazon and want to consider alternative methods, maybe there's a cost issue, you can bring workloads out of Amazon very easily because the connectivity is so clean and precise. If you want to use multiple clouds, and this is really something that we're doing some innovation with, typically the way cloud providers work is they don't want to make it easy for a Microsoft Azure consumer to engage with Amazon and use resources. We can actually build a fairly low cost routed connection between multi-clouds, and then we're actually able to move workloads back and forth between clouds. This is not heavily utilized in current models we've done, but I think it's a really sweet opportunity to consider. So I've talked about all of these things, but there's a couple of things I wanted to sort of emphasize further. Is not only are the services that I showed available, but as an example, Oracle Cloud is connected here. So if you're using Oracle as a ERP solution or a financial system, you can interconnect with the Oracle Cloud. You make your finance and accounting team very happy. You can simplify all of these contracts. We have one example of a customer that is almost in love with the solution simply because of contracts. And the reason is because instead of having to have many contracts with many providers, we can build this in such a way that it is a single contract, single legal agreement, and then a series of schedules. I want to consume a particular circuit type. I want to consume internet. I want to consume Amazon directly. I want to access to the Boston Internet Exchange. I want to do a virtual router. All of these things can be scheduled. I can do security. There's so much advantage to having a simplified contract. Your legal team is happy, they review once. The IT team is happy because they can be more nimble and make changes. Scaling up and scaling down is huge, because if you today make the mistake of saying I signed a contract for 500 meg and I'm hammering that and I need more bandwidth, to get to a gig is a whole new contract. In this model, in 24 hours with a change order, we can change you to a gig. We can get you to 2 gig. So it's a really powerful simplification of how contracts work. And then, just to highlight growth a little bit more. So, and I talked about a few of these with circuit growth. The other thing could be if you're looking at consuming resources in different ways based on enhancements within cloud providers. So these cloud providers are starting to become very competitive. You could imagine that today you're optimized for Amazon, but Google's trying to win your business because they have certain things. If you want to be able to do high performance computing, you can interconnect that with this. You can even put things co-located within the data center, land them on the fabric. If you decide you want to move physical infrastructure to virtual infrastructure and you're not quite ready to move that to a cloud, you can drop that into the Markley cloud, which is basically a virtual infrastructure running out of the Markley data center. We're utilizing and leveraging the Markley cloud for virtual network and security infrastructure. So the possibilities are endless. And what we've been really enjoying as a shared team, Lee, myself, and all the folks that work on this, is we get to do traffic engineering where we can solve problems really quickly and in exciting ways for customers. So in essence, what I hope we've learned a little bit about today is that the fabric is definitely a speed advantage because we can improve the latency. Latency equates to performance experience of users. We can increase or decrease that speed with simple contract changes. We've simplified everything because we've gone from this very complex left hand of the equation structure of getting circuits down to where they need to be, and right hand side of the equation of you can't really access these services without multiple contracts, multiple cross connects, etc. So simplicity is dramatically improved, visibility is improved, and security becomes the next horizon. And again, hopefully we'll have many of you in future presentations we're going to do, because we're going to talk a lot more about security. But just to give a little tip to that, what has happened in the security domain as we've put a lot of these solutions out there is customers have been coming up with their own architectural ideas around how to add security as a service. I've had numerous people say to me, is it possible to consume security out of this data center, out of this fabric connectivity as a service to me where I don't have to think about it? And the answer is yes, but it depends on what you're trying to accomplish. So we've really been enjoying creating these architectures primarily driven by security. And that doesn't even take into account the security and sort of repair work we're doing in a lot of Amazon environments, which have primarily been built for connectivity, but without enough consideration for security. So that's really it. That's the story. That's the story of the fabric, and it's got this beautiful brand title here, One Connection, Infinite Connectivity. And love to hear some questions now, and I'll probably direct a lot of them at Lee if people have posted questions, because Lee is really the brilliant mind behind this. So Lee, do you want to add anything to what I said that might be interesting for people?
No, I think you covered it pretty well. The redundant optical spans that Markley has going right down to US East 1, primary as well as secondary, are both about as low latent as you can get at 12.5 milliseconds. A lot of times, carriers get a redundant circuit, but it takes a circuitous path and can add 10, 20, 30 milliseconds round trip time on in the event of a failover scenario. But with the fabric, our connectivity, both primary and secondary, shares again, while having no common point of intersection, has low latent connections down to US East 1. So that's kind of unique and neat. And we have optical encryption across all of our pathing between our data centers at Boston and Markley Lowell. So security, even down at the PHY level is baked into everything we do here.
And one other thing, Lee, I think would be great if you can just give a little tip to, because you know this better than I do, is the local zone. And I know that there's still a lot of construction happening there, but is there anything you'd want to add about local zones?
Just that it is AWS's way of bringing some of the core services such as EC2, EBS directly to users in the New England region. So US East 1 is based in Virginia, but you can fire up resources in the Markley data center in the local zone and have your compute and your storage within the same building. So it's like a mini region that essentially lives, down the hall from many of our customers' equipment and cages.
That's great. I think with the expansion there and some of the life sciences opportunities, it's going to be exciting. Great. Okay. So without any questions, let's just go to one more thing here. We got one more slide, which is just a tip to the next presentation. And I'll just say that for me, I think this would be a pretty important presentation to come to if people have availability and interest. And the reason I say that is because the presenter is actually a renowned wireless expert. He's pretty much dedicated his entire career to the world of wireless, and I've worked with him for about 15 years personally, and finally convinced him to join us and help us build out a wireless service. And it was just in time, because I would say all, if not almost all customers over the last year that we've worked with post-COVID have had wireless issues. And, he can really talk about the reasons why those things have happened and how we're sort of bringing some new technology that's just coming out in the venture capital sponsored startup company world. We're bringing some of these solutions to the table that are kind of creating a whole new magic quadrant, which is this area called Wi-Fi assurance. So if people are available, love to love to have you join this, and it'd be a really great learning opportunity about Wi-Fi and what can be done to improve it.
Thank you, Mike. And for those that obviously registered for this series, you are already going to receive the links for the World of Wireless webinar that is next Wednesday. In the Q&A forum, there is also a survey link that if you could please fill out in regard to today's presentation, that would be greatly appreciated. We thank you all for your time, and we look forward to seeing you in the next 3 webinars.